So welcome back. This lesson we're going to talk a little bit about multiplication division equations. So what we're going to do is we're going to try to build a pathway to a little bit more of what we call algebra thinking, and one of our goals here is to work towards percent applications. So some of these things we're doing right here are ways to solve percentage problems as we move closer. Something to bring to our attention though is this concept of multiplication. Multiplication has this special property called commutative associated with it. And remember, commutative kind of implies that order does not matter. I can rearrange the numbers. So, for instance, if I say 6 times 5, that's the same thing as 5 times 6. So 6 times 5 is equal to 5 times 6. I can prove that by actually playing it out. 6 times 5 means 6 5s added together. 5 times 6 means 5 6s added together. And we do see that 30 does equal 30 here. So we can prove then 6 times 5 is the same thing as 5 times 6, and therefore multiplication order does not matter. I can change that. Another thing we've talked about, and just want to reiterate that, is multiplying and dividing are called inverse operations. So they work the opposite of each other, if you will. So for us, we also look at this as thinking backwards. So, for instance, if I have 5 times 4, notice how that equals 20. What I can also say then is 20 divided by 4 is 5. Where this statement is coming from is actually going the other direction, starting at the 20, dividing it by 4, and that should give me my 5. So that's what we kind of call this backwards thinking. So if you have a multiplication problem, you can also make a division problem by thinking backwards. So also if I have 4 times 5 is 20, I can also think of this as 20 divided by 5 is going to give me 4. So I can make a division statement. 20 divided by 5 is 4. So for every multiplication statement, there's also going to be a division statement that goes along with that. Where I can use this is, for instance, solve for x. So in this problem here, what we're asked is 5 times some number has to equal 20. Well, we may already know that 5 times 4 has to be 20, so we really don't need this thinking. But you also could, if you wanted to, solve this problem by thinking backwards. So if 5 times x is 20, what this tells me then, if you go backwards, I could say 20 divided by 5 is equal to x. And we could simplify 20 divided by 5. 20 divided by 5 would be 4. Therefore, x would equal 4. So I could say x equals 4 would be my solution. So the answer to an equation is sometimes referred to as the solution, the answer. Okay. So looking at this example, 10 times some number has to be 60. Again, we can probably see that 10 times 6 is 60, so our solution would be 6. 10 times 6 is 60. But if I recognize this as multiplication, I can also think backwards and see this as a division problem. So if I go back this direction, I should be able to see that 60 divided by 10 would have to equal x. And we know that 60 divided by 10 is 6, and therefore x equals 6. So I can express my solution then as x equals 6. Now look at this example. I have 12 times some number is 76. Well, I'm not good with my 12s. But I do know that if this is multiplication, then these two numbers are related by division. So I could find my answer by going 76 divided by a 12, and that would equal x. Now one of the things I see in this problem is this is a fraction, and I can reduce it a little bit. Since these are both even, I can divide the numerator and denominator by 2. So half of 76, so 2 into 76, that would be a 3. 1 comes down, slide the 6 down, 2 goes into 16 8 times, so that's going to be a 38. So that's going to be a 38 over, and 2 goes into 12 6 times. So what I could do then is just divide 38 by 6 now. So 6 goes into 38. 6 goes to 38 6 times, and I get a remainder of 2. And I could say then 6 and 2, 6. 6 and 2, 6. Which I also could say is 6 and 1/3, since that fraction does reduce. So no wonder I couldn't see the answers problem, because it was what we call a mixed number. X equals 6 and 1/3. You also could write that as 19/3 if you wanted to, because we do like improper fractions. So 3 times 6 is 18 plus the 1. That gives me my 19/3. So either one of those would be acceptable answers. So 15 times what number is going to give me 120. Again, since this is multiplication, what I can do is think backwards and use division to find that answer. So 120 is being divided by 15, and that should give me what x is. Again, I'm not really good at dividing by 15, but since this ends in a 0 and this ends in a 5, I know that both of these could be divisible by 5, and I can make it an easier problem. So I could go 5 into 120. 5 goes into 12 twice, and I get a remainder of 20 coming down. 5 goes to 20 4 times. So that's going to change that to 24. And we do know that 5 goes to 15 3 times. And this looks more manageable. How many 3's go into 24? Looks like 8 3's go into 24. So 8 would equal what x is. So I could say x equals 8. So that's the way we could kind of manage that problem. Is remember, division is the same thing as a fraction, and fractions do reduce. We can take advantage of that. Okay. So keep in mind, when we have equations involving multiplication, we can use division as a strategy to find the solutions if we need to. Stay tuned.